يا دكتور. طيب I will start with introduction of what is Arduino. I'm not sure if we have. I think you have all seen the experiments, okay? If not, we will talk about that later on. But to save time, we will start with Tinkercad, okay? So you have to create an account, okay? You will be brought to this website. And then here on the dashboard, you have many, okay? These are the designs that you have done under, for example, 3D or circuits or code block, huh? You have so many things. For us, we will do circuits, okay? And these are some of the things that I have already created myself. So anything will appear here, huh? This is a simulator where you have the Arduino and some of the components, not all, but it is good to start with. It makes things easier, especially in the troubleshooting. Okay. I hope that all created an account, then you can go and create a new circuit.
Yes, I'm working with you. I will do each step with you.
Okay. Okay, so this is the what we call the interface. Here, this is the search menu. For us, what we need for now is the Arduino. Okay, and you have so many types of the Arduino, but we'll take one of them. Okay, so this is the Arduino. Huh? I'll talk about it, and then we might need a breadboard. Okay. Okay, you have so many sizes. See what is good for you, and you can use it. Okay. I'll just take one of them. طيب. We'll talk about how to use it as a power supply first, right? I think it's better to know about the interface and then how to use it as a power supply, and then we can, write small programs. طيب. Let me see if I have that. And this is the Arduino. If you see here, okay, you will have blocks where you can code your program as blocks, and you can have it as block plus text, which also I don't want. So you can see both of them, or you can use the text, which the one that you are going to use. Huh? Okay, so here we have a ready program. I don't care what is the program doing here. Actually, I just want to start like powering, simulating. Just I will use it as a power supply, right? So what I will do, just to make things simple, huh? For the time being, I will have a battery, 5 volts, okay, connected to a resistor, connected to LED, okay, light emitting diode. Clear? So this will be 5 volts, okay. This one could be anything, could be any range of values, but for the Arduino, we want this to be using the least power possible, okay. So to make the power less, we have to increase the resistor, right? So you know that, for example, the V square over R is equal to P, right? This is the power. So the larger the resistor, the lower the power, right? But you have to make sure that you have a trade-off here for the resistor, because very high resistance will make the LED light very dim, okay? If you make very low LED, very low resistor, the power will be high, but also, the glowing of the LED will be high. So I want to do this. Why are we using this resistor? We are not at that place, but this one needs about, from 0.5 to 0.7 volt. Okay, otherwise it will draw large current. Huh? So if this takes around 0.5, this will take the 4.5. Is what I'm saying clear? So we have to use a power supply, but we use the resistor to absorb the remaining 5 volts. So I want to apply this one here. Huh? For those who are not using the breadboard, you can see that the lines here, these are actually one line. This is one line. This is one line. And also these are separated, right? These are not connected. Also here, this is one line and this is one line. And we have the same thing on the other side. Okay. This one and this one. I'll talk from the first basic. So we usually use these two lines for the power supply, although we can apply it directly. So in here, I'm going to put the 5 volt here. And if you click on this wire, you can see that you can change the color. So it is better as much as you can to put meaningful colors, just to make your grading much easier. So this one also, I can make it as a black. All right. So this is the plus and the minus 5 volt. I will use an LED. So I'll put the LED here. Now you can see that this is a what? Anode and cathode, right? Just for a simple test, I'll just connect them directly. This is to the 5 volt, and this is to the ground. Okay, and then I will turn it on. Okay, you can see the glowing, so which means that the direction or the polarity is fine. By the way, you will see it very clear here. By the way, this one has a polarity, so the plus here, and this is the minus. This is called cathode and anode. You can see here, this is the anode and this is the cathode. So this is actually the anode and this is the cathode. So the anode should be connected to the higher voltage and the cathode should be connected to the lower voltage. I did not use the resistor here because there is no harm of using it here, but in the lab for a long time the LED will be burned. So I'm going just to change the polarity. So I will put this one for the plus and this one to the minus. I will just reverse the polarity. Now I'm starting simulating and nothing is working. Okay, is that clear? Just to show you that polarity will make a difference. So I'll remove this one now. Remove this one now. Okay. Right. I will use now a resistor. Bring it here. And you cannot put it here because both terminals will be having the same point, so it is better to rotate it. All right. So actually, I will just follow the same connection. So the 5 volt will go to the resistor. So this one is here. The 5 volt will go to the resistor, which is here. So these are now connected. And then the resistor to the LED here. So the resistor to the LED. And then the LED to the ground. Okay. And then just turn it on. So it is on. Now you can see the lighting is not clear in here. So I'll just click on the resistor. 1K is too high. Actually, you will see it here, but in the lab, if you put 1K, you will not see that the LED is actually turning on. So usually we put this one in the range of ohm, and also we put it as 220, 300, something like that. You will see the difference now. So you can see it's glowing better now. Okay. Any questions?
Glowing better means with less current or with moderate current.
With the less resistance, which means that there is a higher current.
And this resistance is how much? How can we change the resistance?
This is okay. If you click it on here, you'll see it here 220.
I see.
Okay.
Okay.
Right. I will also now use it as a switch. So I'm going to put here a switch in this side. Okay. Just to turn it on and off by using the switch, because this one is going to be used in the lab. So I'll put it here. I just want you to notice this is terminal 2B, terminal 2A. So actually these two are the same, huh? So if you connect one thing here and one thing here, they will be connected directly. Okay. So we usually use this terminal and one of these terminal. Okay. So this is terminal 1B and this is terminal 1A. Okay. So I'll just connect this one to this side and this one. Now, make sure it is connected properly, huh? And this one to this resistance. Okay. Let me make this one to be red. Okay. So now I'm going to turn it on. I'll double only press it. So I'm just pushing on the mouse click, huh? That's all what I'm doing. I'm explaining this simple circuit because the Arduino, the LED, the resistor, the push button, and the breadboard will be used. So if you master this one, it will be easier for you in the lab. By the way, I did not use the Arduino yet to program anything. So before going to the next point, I want to make sure that we are okay.
Yeah, nice.
Right. Okay, so let me talk about a little bit about this Arduino. What is it? Okay. Now, what will happen if you have a laptop, okay, or a PC or something? This is the USB in the lab. This is the USB. You'll be connected to your USB here. Huh? You will write your code here. And you will write it as an extension, for example, .c, for example, M, like in MATLAB. So in our case here, I think it is .ino. Let's call it, for example, P1. What it does, actually, it converts this one to the machine code. This is the microcontroller. So it will accept, for example, .h or .hex file. You understand? This is the machine code. Okay. So it is transforming this code into here. And then it's going to be uploaded using this cable. This one can be used to power the Arduino. So after your program from here, what you can do, you can actually remove the connection, and then it will be running all the time with the power. Okay, I want you also to notice the other connection. So in here, you can see that here, 0 and 1, these are 2 pins, but they can be used as TX and RX. So this is transmission receiving, and you have another device that you are using as transmit and receive. You'll be using it this way, huh? But try to avoid using 0 and 1 for the time being. I don't want to go into details. Am I clear? So we can use the other numbers here. These are the pins. So this is from 2 to number 13. Okay. So this number 2, number 3, 4, and so on. And this is the ground. I'm not going to explain everything, huh? Because we're not going to use everything here. So mainly we are going to use these things, the ground either from here or from here, or we can use the power supply in here and in here. And also we will use this one. These are called analog in. Okay. This one is actually the microcontroller. Huh? We call this the microcontroller. So this is actually the Arduino. It's not a microcontroller. It is a microcontroller-based system. Okay. I forgot the name of this microcontroller. We can see it in the description. These two, the TX and the RX, these are two LEDs. Okay, Shabab. And they will be turning on and off when you have a connection between, for example, your USB from this side, whether you send this way or this way. You will see these two turning on. This one is an LED. It is connected to pin number 13. So if you have any question, please, just ask directly. You can interrupt me.
Yes, Doctor, there is
Yes, go ahead. Oh, people in the waiting room, sorry. Okay.
So, Dr. Ibrahim,
Yes.
the laptop is only connected when we need to download the program on the Arduino, right?
Yes.
That's it.
Okay.
During the lab.
Yes, we will talk about that one, but for the time being, let's use the simulation.
Dr. Ibrahim,
Yes.
there is one of my colleagues want to join the meeting. He waiting for your approval.
Yeah, I just noticed. Yeah, I just did let them all in now.
Okay. Inshallah.
But I suggest Shabab, okay, for all. Okay. So is your friend here now?
Yes, I'm here.
Okay. طيب.
Yes, I'm here. And there is Abu Bakr also waiting.
He's also here. Everyone is now here.
Okay. Thank you.
Okay. So now what we will be using, as we said, I'm going to use these things. I'll use these pins. Avoid using the 0, 1, and for the time being. And these things are going to be used. And you know, the 5 volt, the ground, and the other ground, if you need it, maybe you will use 3.3, maybe. Okay. So let me just go to the code here. I'd like to explain the code. طيب. طبعا these two is for comments. Okay, so I'm going to remove them. Stop the simulation. Okay, so I'm going to remove this one just to make things easier. Okay. Okay, so what you will see here, we have this area to be for global definition. Anything that I define here will be defined everywhere. This is a void setup loop. Okay, it is written like this. Void, yeah, if you remember, it does not return anything, so I don't have anything in the parentheses. And I have this, and I have this. So whatever is inside these two parentheses will be run only one time. That is why it is called setup. So let me just clear all of this. Okay, I will put here, instead of this, I'll put 13.
Assalamu alaikum.
Alaikum salam.
Yes.
Yes.
How did you open this code? Because I tried to open it, but it shows me something else.
Okay, did you enter the Tinkercad?
Yes, I entered the Tinkercad.
Okay, when you enter Tinkercad, you will see on the left side there is a circuit connection.
Yes, I create the circuit and
you go to a new design, and you
yes,
come here.
Okay.
And then, okay, let me just do this one. Click on the code. This is to bring the code in and out. Here there is a search. Okay, so what I wrote here is Arduino. Okay, this one, and we have the breadboard. And by the way, if you write Arduino also, give you different options. Okay, you can, if you see here, you can bring the Arduino connected directly with the power supplies.
Okay.
You can see.
Yes, exactly.
So it's already connecting the 5 volt and the ground to the circuit, and this resistor was not here. Okay.
Okay.
So
yes.
that's what I did actually. And the other components, you can always search for them.
Yes, I understand it. I understand all this one, but I click on the code, but it showed me something else. So I don't know what.
Now, if you press the code, you are using the blocks. Okay, just click on it and use the text.
Okay, I see. I see. Okay.
Are we all on the same page now?
Yes, exactly.
Right. This is LED built in. It's actually, a variable defined. So it is actually like pin number 13. So he's referring to this pin, D13. But I don't want to complicate it. Just I will write 13. So why are we using this? We'll use this. Okay. The pin mode this is the pin number. So it could be any of these, Okay, and then you are going to use it either as an input or as an output. Am I clear? So this is the way to be written. I just want to open the Arduino IDE We'll talk about that one later.
So, okay, I have a question, please.
Yes.
So if I understand, when you give the number, so you define if it is an output, this is where you define it, you mean?
Yes.
Okay.
Actually, I want to download the Arduino, but the problem with my laptop is that it must have like a permission from the ITC, so I cannot download it. If you have it later on, you can just copy and paste this one. And if you write pin mode in the wrong way, it will be black, or it will be like orange or other colors. So if you see here, this is pin mode, pin, all of them are small, M capital, and all of them are small. So to be like this, pin mode. For example, number 3, input, and then you have to put the semicolon. Okay, if you don't put the semicolon, it will give you an error. Okay, so in this here, what will happen? I'm going to run whatever inside this brackets one time. So the execution will be running this way. It will finish this instruction and then this instruction. Then it will enter the other loop. It will execute this one. So that's why it is called also void loop. This 1, 2, 3, 4, then it will repeat. So it is a loop. So this will be like an infinite loop. Is that clear? Okay. So let me just run this program. I remove this one. I'm not using any input. Okay, and then turn it on. What you will see here, you will see the LED turning on and off. This is actually built-in LED connected to pin number 13. So what is happening? I just turn this one to be an output. You have to make sure anything that you turn on, like a fan, an AC, this will be an output. A motor, this is an output. Anything that is going to sense something, it will be like an input. For example, the switch, the temperature sensor, the pressure sensor, all of these are considered as an input. So I'm going to turn on the LED. That's why I'm putting this one as an output. Is that I'm saying clear? Okay. And then here, what is happening? I did not change, but just to make things clear, I'll put this one 13. And I'll put this one also as 13. Okay. So what is happening? By the way, we are actually using this number 13. It could be, so I have this table, huh? It could be an input and it could be an output, huh? Okay, Shabab. For each type of input, I can have digital and I have analog, huh? And general, and this is general. And also for the output could be digital, and could be also analog. Okay. So if I am reading anything, if I'm going to read from a sensor, what will be the instruction to be used? It will be like digital, capital R, read. Okay, and then from which pin number you have to specify here. If you want to read analog, you have to say analog read. And you should also specify the pin number. For sorry, this is actually for an input, huh? This is wrong. This is for an input. Okay. For input, this is digital read, digital analog read. For output, so if I have an LED, either it's going to be either 5 volt or ground, I will consider this one to be digital. Or I can change it in between different values. Yani, the lighting will be different. So it will be from 0 to 5 volt, I can give any value. This will be analog right. So I can see digital right or analog right. In here, what he's doing, he is digital right. So the W is capital, huh? Since I'm using right, this is actually an output, huh? It cannot be read while this is an output. It must be output. Okay. So what I'm actually writing at pin number 13, which is this one, I'm writing high, which is actually 5 volt. And I have a delay here. So it will be high for this unit is actually millisecond. Huh? So 1000 millisecond, it means that it will be on for 1 second. Then digital write 13 low for also one second, which is 1000 millisecond. I just want to experiment with this. So what I will do from here, delete this one. Okay. What I will do now, instead of taking this one from here, I will take this one from pin number 13 to the resistor, to the LED, to the ground. So actually what I'm doing now is this circuit. So this is pin number 13 from your Arduino. And then you have ground. And then you have a resistor and then LED. Okay. So if I say digital write high, this will be transformed into 5 volts. So in this case, the LED will be on. If I'm saying digital write low, what will happen is that both of these will be like this, connected to ground. Okay, so both of them are actually the same point, ground. And this will be off, and this will be on. Okay. Let me now try to run it. By the way, if you double click on any line, you can move this one to make your circuit look better. Huh? Double click, just move it. Okay. Let me look at the code again. What will happen? Digital write 13 high for 1 second, then low for 1 second. And then it will repeat. Huh? It's going to be repeated from here to here. So let me start simulation. Can you see both of these two now?
Mm.
Can you see this LED and this LED are connected together? So actually this is a built-in LED. This is the output of LED. Is this clear, Shabab?
So this one in the Arduino, it's always this is output LED. Yeah, this one.
This one is actually a built-in LED to pin number 13.
Always 13.
Always 13. Okay. So if you turn 10, this will not turn off. So this is actually, it's something like this. This is built in to the ground.
Yes, only with 13.
Only with 13, yes. Okay.
Okay.
Okay. Now I want to move to an experiment. Let me see if I have one of those experiments that I have. I'll just take it from EE391, which is almost the same as what we have in EE235. So I'm going to use maybe it's better to use. Okay, let me see. 2, 3, 5. Okay, let me just take this one. All right. I'm just waiting for this to open. Okay, so this is the manual. I just want to go to the experiment. Okay. So this is the experiment. By the way, there are too many details here. Okay, but usually I do not go through the details of everything. I believe that and this type of learning should be learning by doing. So you don't need to go through all of these details in here, like 16 megahertz quad crystal, AC to DC adapter. There is no need. They will not understand this. There are lots of explanation here that you don't need to go through them. Okay. By the way, you will see differences for the Arduino. Some of this is like an open source, so you see many manufacturers, like it might be the microcontroller. In other Arduino, you'll see something like this. Small square will be the small microcontroller. Okay. So this is we have done. The one that before we come, this is actually using as a power supply. So this is just put a switch, turn on and off. And in here, he's actually going to have this one as an input and then going to turn LED. We have 3 LED, we have button, but I don't want to go too complicated here. Let me just come here first. Yani, what will happen if I remove this delay? And this delay. I remove both of them for now. Stop simulation. Okay. You can actually do it or even comment it. Okay. So what will happen here? I have 2 instructions: digital write and digital write, low and high. So what will happen without the delay? Can you see it? It's on. Can you see it always on?
Yes.
Yeah. What is the reason?
Because there is no delay between the on and an off switching.
Exactly. Although there is an execution time for this one. This is around 1 microsecond, and this is 1 microsecond. Can you see that every microsecond this is turning on and off? So you need the delay, huh? So what will happen now if I just return one of them in here? Okay, so I'm going to return one of them. Let me put this one also. But I will comment it. I just want you to understand the meaning of the delay because it's also important. Same thing, right? So what is it doing? It is turning on and then waiting for 1 second, then turning off and directly turning on. There is no delay. Huh? So let me now remove the second one and the first one and put return. What do you expect will happen now? If you can read the code. So it will turn on, no delay, directly it will turn off. Delay of 1 second while it is off, turn on and off directly. So you will see this most likely off all the time, right? You see it very, for a very short time it's on. Can you see it? I hope you can. Let me just put it as 1 ohm. Can you see it? There is no time actually to become on, okay? So that's why we need both of them. I'll put it as 220. Stop.
So when the resistance is 1 ohm, it doesn't limit the current you are saying?
1 ohm. It will make the current high, but I can play with the simulation for the explaining purposes, right?
Yes.
So imagine that you did this in the lab. It will be like around 4.5 divided by 1 ohm. What will be the current? 4.5 ampere. Is that high or not?
Too high.
Yes, so high. So that's why we are using actually the 220. If you use 220, you can see it here. It is on, right? Let me just try to make it high. Let me change it to K, just to show you the difference. Huh? Where is the K?
It's down.
Yeah, okay. So barely you can see it on, huh?
Yeah.
You will see it on here, but definitely I am sure that if you go to the lab, you will not see it on. So this is high resistance is good for the power, but it is too big that you'll be able to see the LED turning on and off. Okay. That's why I always make sure that you use this one as on.
Because the current is very little when you increase the resistance.
Yes, you need a moderate amount of current. So I think 220 to 330 is fine. Okay. Now, what I will do, just to make it simpler, I will have a switch as an input. Okay, a switch as an input. Okay, and then, or let's say not a switch, I'll call it push button. Push button and LED. If this is pushed, if this is like on or pressed, the LED will be on. If I'm removing my hand from the switch, this will be off. Okay. So clearly, I can use, for example, pin number 13 as an output. So in here, I'll stop the simulation. I have pin number 13 as an output, and this is what will happen. So I remove this one. What I need a switch and an LED. So I have one of them to be an output, right? So the push button is actually input, right? And the LED is an output. Am I right or wrong? So what will happen here? What changes will happen here? I will say pin mode. I want to use, for example, I told you to avoid 0 and 1. Use, for example, number 3 as input, right? Is this clear?
Yes.
Yeah, but by the way, sometimes you will see students that are not putting, I don't remember, there is a default, the pin, if you don't say it, it's either input or output. I don't remember, but you don't need to remember it. Just make it as an input and output, and that's it. It will solve the problem. You don't need to go over to see if this by default input or output. Am I clear? So these two, I will consider them as a must. And then what I'm going to do, I will use a variable. Let me call it a switch. Huh? Okay, to be digital read from where? From my input, which is 3. Okay, and that's it. Okay, so I just want you to go through the errors that will happen. Let me run this one and see what type of error I'm getting. Because this one is also one part of your job to discover where is the problem. If you read here, error, I'm not sure if this is clear or not. it will say error SW was not declared in this scope, which means that it has not been defined. So you can either do it this way, integer, or I prefer myself to define it at the beginning for your level. Now, integer SW, don't give it any value. Okay, I'm going to read it. So if it is reading low, it will be 0. If it is reading 5 volt, it will be 5. Okay, now let me just run this one to see if there is an error or not. Nothing, and there is no need actually for this one. طيب. My output now is actually through number 13 to a resistor, to an LED, to the ground, right? But where is my input? My input is
pin 3. But,
I have to use an input, right? So I have to use a pin. Am I right or wrong? Let me just remove this one here. Okay. So what do I need? I need a switch, right? So this is actually the circuit. I have this pin number 13 to a resistor, to an LED, to ground, right? Am I right? Then I need another input, right? So I have a switch. Okay. I have a switch like this. This is to pin number 3, and this is to the 5 volt. Do you agree or not?
okay.
Yes. Okay. So when I push it,
Hey, you can put this switch to any pin, or it has to be number 3.
no, it can be any pin, even the output.
You can use any.
Yeah, even the output. I just put it to number 13.
Okay.
But if you make it to 12 here, you must change it in the code here.
Yeah, of course. Yeah.
Okay. So
Yeah.
what I will do, I will put my push button now. Push. Okay, I'll use this one. Okay. So you see here that, let me just make this one, right? If you push it, it will be connected to 5 volt, right? If you unpush it, it will be open. Okay. So what will happen? I will take this one to the 5 volt. As I told you before, these two are the same point. These two are the same point. So I'll take this one to the 5 volt, and this one to where? To pin number 3. Okay. I'll just make it. I'll just make it green just to distinguish. This is green. Okay. So let me go to the code. What do you want to do? Is the connection clear, by the way?
Yeah.
Okay. So what I want to do here, that I'm going to read the value. So I'm going to read the value. Read the switch. Read switch. If it is high, then LED on. If it is low, LED off. Clear? So what I'm going to do, I'm going to read. So what I have to give an if statement. If SW equal. You have to put double equal. If you put 1 equal, it will give you a problem. The code is running, but sorry, there is no error, but the code is not running properly. This should be equal to high. Okay. What will happen? Please, at the beginning, just open and close the bracket, because most of the times students will have an if statement, then a for loop, and an else statement. If you don't close the brackets, you might lose track of them. So if you see, I am opening and then enter, close directly. This is 1 point, okay? So that you don't lose track of your brackets. Otherwise, you run into problem. So what I will say, that if the switch is high, then I will say digital, right? Number 13 to be high, right? You can see the indentation also here, right or not? Can you see it? I'm doing indentations to make it more readable. Otherwise, it will be difficult for you to read, huh? Especially if you have many students and you want to like check their code very fast. If they don't write it properly, you cannot keep track of them. And then here I will say else. Open and close. Okay. Low.
Is it case sensitive? You have to write in capital or?
Yes, it is case sensitive. So this is, I wrote it R capital, so I have to write it small. Okay. There is a mistake here also. Okay, this one. Now let's see. See, now this is a very simple program. You have two brackets here, right? Okay. And for one statement, you don't need the brackets, but I'm just trying to make it more general. Huh? So let me just run it and see what will happen. There is an error. Okay.
Semicolon.
Semicolon, exactly. Can you see it?
Yes.
Expected semicolon. Okay.
Semicolon.
Yes. So please always try to read your error. It will help you a lot. Okay. It's working fine. See, I'm not pressing anything. It is high, right? You think there is a problem somewhere? What do you think? Anyone can?
Delay.
No, the delay has nothing to do, right? If I'm pressing and did not change my status, it should be on, right? By the way, what will happen now? What is it doing here? In a very fast move, it is actually reading. What is the status of the switch? It is reading that one. Then it will check this one. If this is true, it will run this one. If it is not, it will run this one. And then after it finishes nothing here, it will read this one again. So it is doing all of this continuously. But it is always on all the time. There is actually a problem, or there is a catch. Okay. You are reading. What type of reading you are doing? Digital read, right? Okay, let me review my connection. It was like this to the 5 volt, right? And this is to pin number 3. When I press the button, it will be 5 volt. When I release it, what happens? Is it 0 or open?
Open.
Open. This is undetermined state. You remember from logic gates, if you don't provide 5 volt or ground, okay, you will be ending up in a problem in the multi-stage system. So what should I do? I should have a pull down resistor.
Yes.
Okay. What should be the value of this? Either too high or too low. Okay. So let's see what happens. Now, if nothing is pressed, by the way, the input resistance here is very high. Huh? So it's actually, if you don't put anything here, this is connected to the resistor to the ground. Do you understand? Am I clear or not? If I don't put it, it is through the resistor to the ground. So actually this is grounded because there is no current. The input resistance is too high. It is like an open circuit, right? So it's like this. Now, this point is actually the same voltage as this one. There is no current here, so the voltage here is 0, right? What if I connect it? It will be 5 volt. Okay, so 5 volt, and this is open. So this is 5 volt. So when I press it, it is 5. When I unpress it, it is actually through the resistor to ground. Is that clear? Yes? No? What is the difference between these two? Okay, this is through resistor to the ground, and this is 5 volt. And the other one, 5 volt. This is to pin number 3, and this to pin number 3. Now in the open state, what is the value of this voltage here? It is open circuit, by the way. So this is what? Ground, zero, right?
Zero.
What about the value here?
We don't have a reference.
You don't have a reference, it's open. So it is undetermined state, right? That's why I'm using this resistor, okay? So if you do it disconnected, this voltage will be zero, right? If you push it down, this will be connected to 5 volts. So it is now reading digital 0 or digital 1. Okay?
Yes.
Okay, what should be this value of this resistor? Okay, what do you need? You need to consume lots of power or low power. Remember, the Arduino has a limit in the power that it can provide. Usually, we'll try to make the power as minimum as we can, right? So if you want to have like a low power, what should be the resistor here? So P equal
High.
to 5
High.
square over R. So this should be very high, right?
Very high.
So can I make it very high? Yes, I can make it very high. Is there a problem? Yeah, is there a trade-off? Here also, this resistor, I want to make it very high, but I have another limitation that if I make it high, although the power will be very low, but the LED will be off.
Will be off.
In here, I don't have this restriction. So I can make this one to be 1K, for example. So 5 volt square divided by 1K, this is very small, right? So let me just do the connection again. Make another resistor. Okay, this is the one. Okay. So this should be in here, right? Because these two are connected, right? These two are the same point. Is this clear, Shabab?
Yes, yes.
Okay. So the other side, which is this one, let me try to make it or rotate it. So the other side should go to the ground. If you are connecting the ground here, will be fine. So you can like take this ground. Okay, make it a black. And this one black. Okay. Now let me try to run it. Okay. Now this is open, right? This is the connection, by the way. This is the 5 volt. This is open from here. There is nothing connected. This one is connected to pin number 3, and from down, it is connected through the resistor to the ground. Is this the same thing?
Yes.
By the way, this is the most difficult part for the student. Okay, now let me try to see. I'm pressing now. My hand is on the click mouse, okay? Now I'll remove it. So it's turning off. Is this clear? I hope we don't have a problem in here. I'm just moving very slowly, so we're going through the basic. Yes, if should I wait like for 5 minutes? You try something on your own? Or should I continue?
Continue, bro. Continue, Brian.
Okay. Right. Let me go now to the experiment. So this one. Now this one, the only difference here is that I'm adding. So this is one LED, another LED, third LED. By the way, if you go also here, like you can change the color of the LED. Huh? You can make it, for example, orange or green. Okay, you can see the color. Okay, so you can use different colors. So what do we have here? I have an input switch here to one of them. So you can see, as we have done before, all of them are connected to the ground, and three LEDs. Let's look at the code. I'll just try to copy it. Okay. Can you see now? طبعا, if you don't pay attention to this one, try like to make it everything. So all of these are actually inside. You can see it is readable, right? So first of all, there is no need for the switch state here to make it 0. Why? Because I'm going to read it at the beginning. So he's making that switch as an input, and he's going to read it. So this will be overwritten. Huh? This is actually was taken from 390. There is no need for this one. Okay. So what do we have? How many inputs do we have? 1 input and 3 output, right?
Yes.
So first of all, you're going to read the switch. If it is low, then, so I will have this table. Huh? If this is a switch, low or high. Okay. So this is actually 3, 4, 5. I want to see what happens. I'm just trying to do it in a table. So if this is low, what will happen? 3 and 4 will be high. So this will be high. And 5 will be low, right?
Yeah.
Then else, what will happen? It will be
No, no.
3, 4 low. So this will be low, low, and then high. Then 4 is high. And 5 is low. He didn't mention
delay.
3. He didn't mention 3. So this will be like low because he didn't change it, right? So what will happen? Actually, if you press 1 time, it will be this one on, then number 4 is on, then it will read again, and you are removing your hand, so it will stay at this stage. I will keep this one as an exercise for you. Just do the connection and run it. Okay. I want to focus on other things. Okay. The only thing here that you need to complete the connection. And try to remove, this delay and this delay, see what will happen. Okay. Also, the other thing, just remove this one. There is no need, actually. This is the
Even if it's there, it doesn't harm, right?
because it will be overwritten when you come here and read it.
Okay.
There is no use, actually, of it. Huh? طيب. هنا he's modifying the code, so he will have maybe the difference here and here you can see. I'll just... okay. Here he's using the input as number 2. And here he's using the input as number 7. Actually, keep it
7.
Keep all of them 2. Okay. There is one catch, okay, that I want you to do. When you go to the code here, sometimes, you go to the Arduino here, there is a broken wire inside, for example, number 2. Okay. Like you did your connection, you put your wire and it is cut inside. So you cannot actually put anything inside. So usually it is better to do it this way. I usually integer, for example, I'll do it only for one of them. LED1 equal to 3. Okay. Imagine that you need to change the 3 everywhere now. You have to come, this one change it, make it 10, for example, and you'll come here, make it 10, and you'll come here and make it 10. It's a long process, especially if the program is big. Huh? But if you keep it this way, this LED1, and then LED1. I'll just do it for 1. So if there is a problem, instead of changing all of this, you just change this one and make it 10. Is my point clear? So you can also call this one LED2. So you can say integer LED2 equal, so this was actually 3, 4, and integer LED3 equal to 5. Okay, so in this case, if you change all of them, any change in any wire, there is a problem. You just need to change the number here instead of changing all of it inside the whole code. Is my point clear? Yes, Shabab? No, yes or no? So here I'll change this and make it LED2. This is LED3. Also, you make this one. So you need to do this once at the beginning. So this is, and so on. Huh? So you don't need to change all of your numbers here. Just change it here and everything will be changed inside.
Yes. So instead of defining the integer in the middle, you are defining at the beginning, so that, and then you are calling LED 1, 2, and 3.
Yes.
So change will be only in the first 3 lines. That's it.
Yes. In case that you have a problem here, for example, in one of these, because sometimes it happens, there is a broken wire here, or just the wire was there and then it has been cut. So it is actually in here, especially in the project. Okay. When you want to do like run many times to check if there is a problem anywhere, you can just change this very fast. Huh? It's just one line. Okay.
How do you identify that there is a broken wire there? And I mean,
you can see it. It will be clear.
okay.
Okay. Plus, you don't have a restriction here. Huh? Just you can follow their program very easily. Also, when you read it. Huh? Also for the input, if you have more than one input, for example, temperature sensor and pressure sensor, it is better to use, defined variable properly. Okay. So the only difference here, this is the second one, right? Oh, this is the first one. The second one is here. The only difference on this code is actually the pattern. No? Just the if and else. So this will be a different pattern, and else, this is if it is high. If you keep pressing your button, all of them will be on. Okay. This one, actually, there is no need for this one. He's saying that in here, that, okay, and instead of putting high, put, for example, let's call this one SW, put it SW. For low, put it not SW. Okay. Which actually, this is wrong. This definition is wrong. If you experiment with it, it will not work properly when you use your variable as switch and not switch. It will not work. Okay, so this one I usually avoid, and there is no need actually. Okay, then in here there is something. Okay, we'll look at this one later, but we are going through the basic. I want to go to the other experiment now. Which is the temperature sensor. Okay. Okay. So first of all, I want to go through what is the meaning of analog input and analog output. So I would like to do something here. I will write a small program. Okay. Let me come here. Okay. Are you all following still? Okay. Let me remove this one. And let me use just a temperature sensor by itself. I will use just a temperature sensor. I will move the switch for the time being. Oh, it has to stop. Okay. Can you see this now? It will show you here that there is a power and then ground. So I can put the ground here. And I can put the power through the other terminal from here. Okay, I'll change this one to red. Okay. Now, what I want to do is to try to read the value and just display its value. So I'd like to understand what's happening. You as an engineer, usually when you are getting components, you have to know how to use them. So just try to write a program to read the values, okay? So what I'm going to do, this will be a temperature, right? By the way, temperature, is it analog or digital?
Analog.
Analog, right? So I should read it through analog read. If you see here, there is analog N, right? Am I clear? And
Yes.
these are the pins that you have to put them. Okay, so there is no need actually to define them to be input because they are analog in. There is no need to define. Okay, if you look here, by the way, we said that we did say about digital input or digital output. So this is analog input. Where is the analog output? Anyone, like if you come here, you see at number 11, you will see this twiggle, right? Number 10, this is actually this twiggle. So these two, so this one can be used as analog, digital input or digital output. Do you agree? 13 and the 12 and any of them. But 11, for example, it can be used as digital input, digital output, plus it can be used as analog what? Output. Okay. Is that clear? So this is the analog input. This is the analog output from here. Anyone that has one of these, I cannot use analog output here. Huh? Okay.
Yes.
And all of these can be used as digital input or digital output. So what I want to do, I want to read the value and just display it to see what is the effect that we have here. So what I will do, I will take this one to, for example, A0, right? Okay. So let me come here. Forget about the connection. I'll just keep it because I don't want to repeat everything. So let me remove all of this here. Let me remove all of this here. Okay. I just want to make it very simple. Okay. Now you have your laptop in here. As I told you, this is connected to here, صح? So what do we do? What do you do when we say simulate? Simulate, it will download this code in here, right? And then it will run. Also, I'm powering, by the way, if I'm using this USB, I am powering also the Arduino. So what we do, we write our code here, right? And then we send it, upload it to the microcontroller, and then there is no need for this cable. For now, I would like to read the value from here to here and display the value to the serial monitor. It is called serial monitor here through the USB. Okay, so I'll just give a simple example. If you have a TV at home, you want to watch the TV, what is the first thing that you need to do? You need to turn it on, right?
Yeah.
Am I right? So
Yeah.
we'll come here, we'll say serial. This is this configuration, serial dot begin. Okay, 9600. Okay, so I'm just turning on the serial monitor, which is actually the serial channel here and this one. Okay, so why am I saying dot in here? So serial is the object. For example, I can say I have a car, and I can say car dot forward, car dot backward. This is called object-oriented programming, if you are familiar with something called method. But the print function there, it is not attached to anything. And here I have the same thing. I have an object called serial. The object is serial. The instruction is the begin. Okay. You will understand now. So I will say here, analog read, right? It's an input, right? So I have to read. What type of input? This is analog input. So I have to read it through A0. This is where I connected my value, right? But I have to put it into something. So I will say value. Let me call it read value. Huh? Read val equal. And then I'll define here integer read val. Why did I put it as integer, not float? There is, by the way, the types of variables that we have, either integer, float, or character. Why did I put it as integer? طبعا هنا يا شباب I'm powering the temperature sensor by voltages, right? So actually this will convert the temperature into voltage. So what are you going to read through here? You read voltage, right? Am I right or not? But through something called, if you are familiar, quantization, the voltage will be converted into a value from 0 to 1023. I think this is actually 2 to the power 10 minus 1. Okay? Is that clear? So if you are going to read analog value, it will be different values, but they are all integer. The digital value is either two values, either 0 or 1. Since I'm going to read only analog for now, it will be through these numbers. Okay?
They are unsigned.
Forget about signed, these are just integers. I'm not going deep into what you're saying. Consider them as unsigned.
Okay.
Okay? So now I'm reading the value here, but I also want to see what is this value actually. So what should I do? I should go serial now again, dot print. What do you want to print? Read value that you have done. Okay, and then I'll put just a small delay because otherwise the screen will be very fast. Try to remove this and you will see what will happen. So I'll put it as 500. Okay, now let me clean and start simulation. There is a problem somewhere.
The bracket.
The bracket, exactly. Okay. Okay. So now if you focus here, I'll just zoom in, huh? If you focus here, I can simulate, you know, the temperature. You can see the range of values. In the lab, you will touch the temperature sensor by your hand. So let me just see what the values that we have here. If you come here, can you see the serial monitor now? Down. Just click it. Okay, you can see. Okay. The reason I'm doing this is that I have to print in a new line, LN. Okay. I want just to. Can you see it? Let me just change the value. I'll make it very small. The minimum is going to 20. This one did not go through the full range. Huh? Through the temperature range, the minimum is 20 and the maximum is actually 125. Sorry, 125 temperature correspond to 358. Am I clear? Each of these values represent a voltage, and each voltage represent what? Represent a temperature. So I'm going to print that temperature. Let me just define another variable. Okay. Again, I will say float temp. Okay. Now temp equal to read val. Okay. Multiplied by 5 divided by 1023. Okay, I'll put dot 0 here and dot 0 here. Okay, and here actually, what I did not convert it to temperature yet. 0 to 1023. Since this is the minimum is 0 volt and the maximum is 5 volt. So this should go to 0 volt. This should go to 5 volt, right?
Yes.
Okay, so if I make it this way, do you agree that I'm converting this to voltage?
Yes.
Okay, so I did not yet convert it to temperature. Now, why did I put, for example, let's say 1/2. What is the answer?
1/2.
It's a simple question, huh?
0 volt.
No, just in general, this value, 1/2.
0.5.
0.5. This could be an answer, but somebody else can say, okay, it is 0 and the remaining is actually 1, right? So if you put 1 over 2, this is what you'll get. If you put 1.0, this is what you will get. That's why I'm putting 0 and 0. And that's why I'm putting the temperature as a float. And by the way, I can define this into 2 stages again. I can say that this is actually voltage. Voltage. And then I say temp equal to voltage multiplied by a factor. So I can say also here float voltage, right? Or volt. Okay. What is this conversion factor? So what I have now, I have a value that has been converted to volt, right? So I have a volt. If I want to convert this one to degrees centigrade, what should I do? I should multiply it by a factor that has degrees centigrade divided by volt, right? Do you agree?
Yes.
Yeah.
Okay. So where should I get that factor? Let me go here. I'll just do a simple search. You can do it from the data sheet, but let me just try to do a simple search. Okay, so temperature conversion LM35. Let me see. I'll just take something very fast. Why am I showing you this? Because in a point you need to know what is the conversion factor. Okay, if you can see this one, can you see this one? It's actually 10 millivolt per degree centigrade, right? So this is actually 10 divided by 1,000. Do you agree? So this is actually 1 divided by 100. Okay? Is that clear? What is the unit? I converted to volt per
volt per degree centigrade.
Okay. So what do I need to do if I have that factor and I want to, so actually volt, so this is temp will be equal to voltage. It's either multiplied or divide by this factor. What should it be? Divide by this factor, right? So this is volt divided by 1 over 100 volt per degree centigrade. Do you agree?
Yes.
Yeah.
So this will be equal to voltage. Okay, this will go with this. This will go up. 1 over 100, this will be multiplied by 100, right?
100. Yeah.
So if you go here, you will multiply by 100. Okay, times 100. This should be working fine. So I want to now to print what temperature. I don't want to print the serial, the value. Huh? Okay, so this should be multiplied by 100, right? Let's see what will happen now. There's something, okay.
Yeah, because voltage spelling you have to correct. That's it.
Yes, also the semicolon voltage.
Yeah.
Oh, yes.
Voltage. Yes. Semicolon in the equation.
Because I did not even finish, huh?
The also above semicolon.
Yes. What else? Voltage, not defined. Okay. Let's see what do I have here. Does this make sense?
No, it doesn't make sense.
Doesn't make sense, right? طبعا, this equation is the equation that you're going to use in the lab. If you are going to do it practical, huh? If you go through the research, you will see that there is actually before you multiply, it is minus 0.5. Let me see. Is it here or through the read value? maybe
Is there is overflow?
just a minute. No. I'm just trying to remember. I think it's actually read value minus 0.5. I'll explain it. I'll just try to remember. Huh? Where is the temperature sensor? Okay. Okay. So okay, let me just try to finish. Take this one. I did not do this for a long time. I usually in the lab, this is enough, huh?
There is scaling.
No, it's not scaling. Let me just make sure it is working fine. 25. So this is okay. This one should not be here. I did make a mistake here. Let me try. Actually, I'm multiplying by 100 here and here. Huh? Okay. Okay, you can see it now. So this is actually, I was multiplying actually 100 here and here. In the lab, there is no need for this factor. Okay. The minus 0.5. And here they said that there is an offset value that you need to take care of. Okay. So after you convert to a voltage, you have to remove minus 0.5 volt out of it. Huh? Okay. So let me just change this one just to make sure. So this is now 43. It is 42.86, which I'm actually fine. So far, so good. So far, so good, ya shabab? I'm not hearing any feedback.
Yes, inshallah.
Yeah. There is one thing, and I gave you all the almost the basics, but you need to go through the details of each experiment. Huh? If you go to the codes here, okay. So you need to try this code for this part. Try to do it, but because of time, I will not do it now. If you have any question, let me know about this one. And for here, so in here, it will explain why am I using all of this. Huh? So in here, he's actually doing all of them. So in this case, it's complicated a little bit. So I will say, instead of the for loop, I can say pin mode to output, and then three, and then 4. So what he's doing, he's using a for loop to put all of them to be output and also to turn them all off. There is no need also to turn them off at the beginning, because let's assume that they are on. Directly, when you go into the loop, they will be affected. Okay, so there is no need to turn them off. But I'm sure that actually by default they are off. So if you are going to do it, there is no need for this one. And this one is the same as these 3 lines. Okay, for here, he is defining scissor value. This is the read value, analog read. This is the one that I have seen. These are the type of print. The print or the print ln actually is a new line or not. Okay, this one should be actually 3. So here he's doing the conversion, and then multiply by 100. In the simulation, you just do minus 0.5. Okay, and then here you have if statement. for different ranges of temperature. يعني yeah, if the temperature is just, for example, than 24, all of them will be off. If the temperature is less than 24 and then, sorry, greater than 24 and less than 26, then one LED is on and so on. Huh? This is just to go through this. This is if else statement. And then it will repeat again. These are the Arduino based for the first two experiments. The third one, I didn't do it, but I believe it's not difficult. But this should give you an introduction about these two. And just for the time, I think I have covered what I need to cover. If there is a need for another workshop, but basically I'm done. The other details, just please try to copy and paste the experiment totally and see what is the effect. Also, you can go to the lab and try to do the connection by yourself. Okay. Any question? Dr. Hussein, if you want to leave, you can leave. For the other students who are with me for the training, please stay. And anyone who have any question. I'll just stop the recording for now.
Thank you, Dr. Ibrahim. Thank you very much.
حياك الله. مع السلامة.